Alright, this is APAB, and we're talking about evaluating limits algebraically, which I incorrectly put after one of the 1.2, after the second 1.2 video, but should actually be the first video in 1.3. So you're seeing this a little bit later than I originally said you would. Sorry about that. Alright, so we're going to talk about how we would evaluate limits. Your book calls it analytically, I would say algebraically, but it's the same concept. So I'm going to walk you through some steps. I'm going to list them here, and you should put them in your notes, and they're going to make zero sense at first, but then hopefully as we do problems, they're going to make more sense. So first thing you're going to do is you're going to plug in the value that you're approaching, right? So if it's the limit as x approaches 5, you're going to plug in 5 for x, and if you get a number, that's it. Now I'm going to jump down to the bottom for a sec and talk about how you write limit until you plug in the value. Once you plug in, you can't write limit anymore, and I'll show you what I mean by that. But essentially it's because limit is sort of like a mathematical operation, right? If you write the square root of 1 plus 3, the quantity 1 plus 3, you would also write it as the square root of 4 when you added 1 plus 3 together, but then once you use the square root, you would stop writing the square root and you just get a 2, right? You wouldn't write root 2, you just write 2. So real quick at the bottom here, just to show you what I mean, this is sort of like if I gave you the square root of 1 plus 3, you would make it the square root of 4. See how I'm still writing square root because I haven't used it yet. But then I use the root and get an answer of 2, right? It is not a square root of 2 because I've used it. So similarly, if I have something like the limit as x approaches 5 of 10x, well, when I use the limit, I'm going to plug this x in as 5 and do 10 times 5. Well, now that I've used limit, I don't write it. I just write 10 times 5, which is a 50. So so I have this. See how this is not the limit as x approaches 5 because I've already plugged in 5 for x, okay? So think about it sort of like a square root, like it's a mathematical operation. So we're going to start by doing some of these plug-in problems, okay? So let's do an E1. All right, so for E1, we're going to evaluate the limit. So the direction for all problems, the direction here is going to be evaluate the limit. And that's going to be all of them moving forward, and there's going to be a bunch of them. So E1a, let's do the limit as x approaches 3 of the square root of, let's do 6, let's do 13 plus x, okay? And then b, let's do the limit as x approaches 1 of x squared plus 4x. And for c, let's do the limit as x approaches 0 of x plus 2 over x plus 1. Okay, so let's evaluate each one of these limits. So I'm going to start by plugging in, and if I get a number, congrats, I'm done. That's the whole deal. So even if it's an ugly number, doesn't matter, that's my answer. So I'm going to go ahead and plug in, and notice that when I plug in, I stop writing the word limit, right? And so I'm going to get square root of 13 plus 3, which is the square root of 16, which, oh look, that's a 4, and that's my answer. If I plug in here, I'm going to get a 1 squared plus a 4 times 1, which is a 1 plus 4, or a 5. Now, if you're jumping to this answer in your head, right, if you're able to go from here to here, nobody thinks you're cheating. People think you're sitting in AP Calculus class, and it's totally cool that you're able to do that. It's fine. I don't think it's cheating to jump from here to here. I'm showing you the steps so you get why I'm getting that number. I don't think it's cheating to jump from here to here. Now, as we get to more difficult limit problems, you're going to want to show some work, not because I don't think you can do it in your head, because you're sitting in AP Calc class and it's quite possible that you can, but because if you don't show any work, then if something goes wrong, your teacher has no idea what went wrong, and if it's on the AP and you're getting partial credit for things, showing zero work means that you're not going to get full credit even if you have the right answer. You don't have to show every step, but if there's a lot of steps to something, you should try to show the important ones, right? And then for the last one, when I plug in, I'm going to plug into both these x's, and I'm going to get 0 plus 2 over 0 plus 1. Notice I didn't write limit because I've already used that limit, so I get 2 over 1, which is just 2. And again, if you jumped from here to here, nobody's like, wow, you're a cheater. It's cool. Everybody knows you know how to do math. If you need these steps, also totally fine, right? No judgment here. I'm judgy about a lot of things, but you and your math work needs are not one of them. So anyway, so let's do a P1 that's similar to E1, right? So if you want, I'm going to make up 3 more problems for you to plug into, and if you want to try them on your own, you can pause me and then do them on your own before I do one. Okay? So So that's absolutely fine. So let's do the limit as x approaches 5 of 4 minus x over x minus 3. Cool. Let's do the limit as x approaches 1 of the square root of x plus 3 over 7x. And let's do the limit as x approaches 2. We'll do negative 2 just because it's fun to get a negative, of an x squared plus a 5x. Cool. Okay, so there you go. 3 problems. If you want to pause me, this would be a good time to do it, okay? All right, so hopefully you've tried it and you've unpaused me now. So I'm going to go ahead and plug in the values, right? The very first thing I'm going to do is plug in the values. All of the problems in E1 worked by plugging in, and so will all 3 of these. So when I plug in here, I get 4 minus 5 over 5 minus 3. So I get a negative 1 over a 2. Negative 1/2 is my answer. Negative 0.5 is also fine. Again, if you're able to do this in your head, nobody thinks you're cheating. Now I'm going to plug in here, and I'm going to get a root 1 plus 3 over a 7 times a 1. So I'm going to get a root 4 over a 7, which is 2/7. Again, nobody thinks you're cheating, right? These would not be a calculator level problem, though, so your answer should be 2/7, right? I don't expect most of you know what 2/7 is as a fraction. I expect you could do negative 1/2, no big deal, right? But better to keep it as a fraction in that case. And then here I'm going to plug in, and now notice, be careful, I did intentionally give you a negative for this reason. A negative 2 squared is going to come out positive, right? So I'm going to get that this is a positive 4 minus a 10, so I get a final answer of a negative 6, okay? So again, that's me evaluating limits algebraically when I'm able to plug in, okay? So now let's take it a step up and talk about what happens when plugging in fails. So essentially, if you plug in, you're either going to get a number, right? In which case that number is your answer. Oh, as a side note, and I didn't actually give you this note originally, but so 0 on top of a non-zero number is 0. Okay, so that's a number, right? But so I'm just going to say a non-zero number. I'm going to use the hashtag number, like the number symbol, right? 0 on top of a non-zero number is 0. But a non-zero number on top of 0 is what we call undefined, okay? And we're going to talk about this when we get to 1.5, which is limits involving infinity, okay? So we're not going to talk about this yet, but that's a possibility sometimes. It's just not a possibility yet because we're going to do that in 1.5. And then the third possibility is you could get 0 over 0, which is what we call an indeterminate form. Okay, and there's a bunch of indeterminate forms that we're going to talk about. When we get to L'Hopital's, which is in 8.1 in your book, but we do it in Chapter 2. Okay, we do it in Chapter 2. We're going to learn other indeterminate forms, right? But for right now, this is the only one you're going to learn, and I want to mention it because that's going to be important when we're evaluating these limits algebraically. When you learn L'Hopital's rule, you need to know a little bit more calculus to do that. You're going to learn other ways to do the problems that we're going to spend the next several examples doing. To be honest, though, the other ways aren't always faster. Sometimes the other ways are faster, but not in this particular, not in every instance, okay? So just to be clear, if you get a 0 on top of a number, so for instance, 0 divided by 57 is totally 0. And the way I always remember this is about pizzas, because everything should be about pizza. So if you have no pizza and you invite 57 people and they all want to split the pizza, that's cool. You can invite 57 people over to split no pizza. I guess you'd be inviting 56 because you're probably number 57. So you can invite 56 friends over to split your no pizza with you. They're all getting no pizza and they're going to be pretty surly about it, right? But the other way to think about it, right, is that you can't divide a pizza by 0 people, right? Like, let's say you have 20 pizzas and divide by 0. That doesn't work. You can't break something into 0 pieces. So this number on the bottom, it's sort of like how many pieces you're dividing something into. If you have 1 pizza and you divide it in 2, that's splitting it between 2 people. Each person gets half a pizza, right? So if you think about the denominator sort of in a really simplistic, almost elementary school way of you dividing a quantity into that number of pieces, it makes sense that you can't divide something into 0 pieces because something has to be 1 piece to begin with, right? It can't be 0 pieces. You can't just like obliterate it. You're not like going all Thanos on stuff, right? So anyway, so let's walk through another couple examples. So let's say we get this indeterminate form where we get a 0 over 0, okay? If that happens, I promise you that if you get a 0 on top of a 0, you will be able to simplify the expression using your algebra skills so that you get back to this step 1 and you can plug in and get a number. I promise. If you get a 0 over 0, this thing's going to simplify. Specifically, it's going to simplify basically in one of 4 ways. And those 4 ways are factoring, foiling / distributing, which is sort of like the opposite of factoring, right? Making something into one fraction, and I'll explain to you in a second, and then this thing called rationalizing. So the trick with the 4 of these is that knowing which one to use, so I don't know if you're familiar with the concept of triage, but when you walk into a hospital emergency room, they send you to triage to figure out what is wrong with you, right? To figure out, are you somebody that has to instantly go back to surgery? Are you somebody who can sit in the waiting room for a little bit, etc.? You actually triage things in your daily life all the time, right? Perfect example, it's like 100 degrees out today, right? If I walked outside and I want to see what the temp is, I walk outside and I go back inside and I pick appropriate clothing for that temperature, right? Like maybe I was like, oh, I'll bring a light jacket or I'll bring a hoodie, and then I walked outside and was like, whoa, no, I will not. It's 100 degrees. I don't put on a parka, right? So you triage things all the time. You look at the situation that's presented to you and you make a good choice. You look at the traffic and think, man, maybe I'm going to hop on the subway, not the bus, because it looks like nothing's moving on Broad Street, right? You check out the weather and think, man, it's a blizzard outside. I guess I'm not going to wear flip-flops and a t-shirt, right? You do this all the time. So the idea is that you're going to be presented with one of a handful of opportunities when you look at this, and you're going to say, hey, this is the one that makes sense for factoring, or this makes sense for foiling or distributing. So I'm going to walk you through a couple examples. So let's do example 2. We're going to do the limit as x approaches 1 of x squared minus 1 over x squared minus 3x plus 2. All right. Yeah, and we're going to do a second one. Let's do the limit as x approaches, let's do -2 of x squared plus 5x plus 6 over x squared minus x minus, plus x minus 2. I think I stand by that. Yeah, I stand by that. That's going to work. All right, so let's plug in and see what happens. So when I plug into this first one, I plug into A. The first thing I'm going to do is not write limit and plug in and see what happens. You can do the plug-in mentally just to make sure, because sometimes, right, so let me give you one third one. Hold on. X approaches 0 of x squared plus 4x over x. Cool. Awesome. Legit. All right. Let's walk through this. So I'm going to plug in first. The reason you want to plug in your head is sometimes math teachers, just to be total jerks, will give you something that looks absolutely disgusting that you think, oh my gosh, I'm going to have to factor and cancel and it's horrible. But if you would have just plugged the number in, you would have gotten that the answer was like 5 over 2. And you would be really happy. But someone else is like miserable because they're factoring and foiling and trying to do crazy stuff, and somebody else just plugged in and they're like, oh, this is awesome, I got 5 halves and I'm done, right? So you should always do the mental check to plug in anyway. So I plug in real quick, and you can do it off to the side, you can just do it in your head, I don't care. When I plug in 1, on the top I get 1 minus 1, right? On the bottom I get 1 minus 3 plus 2. That's a 0 over 0, okay? And that is literally never the answer, okay? The answer is never, ever, ever in all of math going to be 0 over 0. So what that means is that I have to be able to simplify this in one of these 4 ways to get something to cancel so I can plug in again. Well, the reason I picked these first is because these are factoring problems. I look at this thing, it is not currently factored. They are polynomials that I easily could factor using my algebra and trig skill, or algebra and pre-calc skills. So I factor the top, noticing it's a difference of squares into x plus 1, x minus 1. I factor the bottom, knowing that the front seats have to be an x and an x, the back seats have to multiply to a 2, which must be a 1 and a 2, and that the plus sign means they have the same sign, which must be this minus. So I get an x minus 1, x minus 2. You should double, like, however you factor, I don't care. You just have to be right, right? You need to be right, and then you need to be quick about it, because as we move forward in calc, factoring is going to be one step in a really long problem. And if you factor wrong, then the rest of your problem is going to go south pretty fast. So you want to factor correctly and then make sure you're pretty quick about it. So I noticed that the x minus 1's cancel. Oh, I said that to say that you should FOIL in your head to make sure you're right. If I FOILed this, I'd get x squared, a minus 2x and a minus 1x, which is totally minus 3, and then a plus 2. And I know the top was a difference of squares pattern. So these cancel, and I now get that this is the limit as x approaches positive 1, rather, my bad, of x plus 1 on top of an x minus 2. Notice that I'm still writing limit because I haven't plugged in here. There are x's, not numbers. Now I'm all clear to plug in, though. I'm going to go over here because I'm a little low on space. When I plug in, I get a 1 plus 1 over a 1 minus 2. So I get 2 over negative 1, or just a negative 2. Notice I didn't write limit once I plugged the numbers in. Just like up here, I didn't write limit, right? We go to do the second one, the same thing's going to happen, and I'm actually going to erase the first one so I buy myself a little bit of space. You can always rewind, right? Remember that 0 over 0, which is what I'm going to get when I plug into the second one, is never the answer, right? So I'm going to go ahead and do my second one. We'll do B. When I plug in, I'm going to get a positive 4, because negative 2 squared is a positive 4, minus a 10 plus a 6, on top of a positive 4 minus a 2 minus a 2. That's definitely a 0 over 0, which again is never the answer, right? It's never the answer. So I now have to go ahead and factor this out and see what cancels. Now my guess is that it's going to be an x plus 2 that cancels. The reason I say that is because the factor that would make a negative 2, the factor that you could plug into to get a negative 2 to give you a 0 would be x plus 2. So I'm guessing that both of these are going to have an x plus 2 as a factor. So I'm going to come up here because I'm a little low on space. I'm going to make this the limit as x approaches negative 2. Well, the top has to multiply to, so the front seats are x and x, right? The back has to multiply if I'm unfoiling, right? Because that's really what's happening here. I'm unfoiling. It's either a 1 and a 6 or a 2 or a 3 because it has to multiply to a 6. This plus sign tells me they have the same sign, and then this sign tells me what they are. So I realized that if I do x plus 2, x plus 3, they FOIL out to a 6 at the end, and the inner would be a 3x plus a 2x, which is my 5x. I'm also not surprised because remember I mentioned that an x plus 2 was likely the factor that would cancel. On the bottom, I'm pretty sure there's an x plus 2, right? So I see that this negative 2 is going to be a 1 and a 2 with opposite signs, and since I was already pretty sure there was supposed to be an x plus 2, I'm going to go ahead and guess that and then FOIL to check if I'm right. X squared, outer is a negative x, and inner is a plus 2x. Well, that would be a positive x, and last is a negative 2. So these cancel. Now I get the limit as x approaches negative 2 of x plus 3 on top of x minus 1, which gives me a negative 2 plus 3. Notice I didn't write limit because I plugged in the numbers now, over a negative 2 minus 1. So my answer is a 1 over a negative 3. And you could make it a negative 1/3 or leave the negative on the bottom. It doesn't matter. Okay, so let's do the last one, and this is the reason I mentioned that you should plug in first. I could factor the last one. Stuff will cancel. It's totally going to happen. However, if I plug into this last one before I bother to factor, what's going to happen is I'm going to get 0 plus 0 on top of 0 plus 0 plus 4. That's 0 over 4, which is a 0, right? 0 on the top is totally fine. And that's the answer. Now, you could have factored, and stuff would have canceled, and you'd still get a 0, but you save yourself time if you just plug in first, okay? So I'm going to give you a P2 that's similar to E2. And again, you can pause before I do it, and then we'll end this video after P2, and then we'll move on to the next skill set, which is the foiling and distributing. So let's do a P2. All right, so same thing, evaluate the limit. So for A, I'm going to give you the limit as x approaches negative 3 of x squared minus 9 over x squared plus 4x plus 3. For B, let's do the limit as x approaches 1 of x squared plus, let's do 5x plus 4 over x squared plus 6x plus 5. Cool. And then for C, let's do the limit as x approaches 2 of x squared minus x minus 2 over x squared minus x minus 6. No, I lied. Plus x minus 6. All right, cool. I think I stand by that. Yeah, all right, cool. So pause me if you want. I'm going to walk through those, but if you want to try them before I do, then you should walk through them by pausing me. So I'm just going to do the plug-in real quick over here. If I plug into this one, I'm going to get 9 minus 9, which is a 0 on the top, over a 9 minus 12 plus 9, or plus 3, which is going to be 0 over 0, right? That's going to be a 9 minus 9, which is 0, and a 12 minus 12, which is 0. So remember, that's never the answer, but it tells me that I'm going to be able to factor. So I see that the top of this thing is a difference of squares, right? X plus 3, x minus 3. I also notice that it's really likely that the factor I'm looking for is an x plus 3, right? Because if I'm approaching negative 3, the thing that would make 0 would be an x plus 3, right? So I think there's likely an x plus 3 on the bottom, and I can confirm that by noticing that my factors have to be a 1 and a 3 with the same sign, and that sign is positive. So I'm going to get an x plus 1, x plus 3. Right, so the x plus 3's are going to cancel. If you don't need the step where you rewrite this without them, that's fine. I can go ahead and plug the negative 3 in. I'm going to get negative 3 minus 3 on top of a negative 3 plus 1, which means I get negative 6 over negative 2. My final answer in part A is a 3. When I plug into the second one, I'm going to go ahead and plug in over here and just see what happens. I get a 1 plus a 5 plus a 4. Well, right away, before I keep going, I notice that that is very much not a 0. So I'm probably not getting 0 over 0 here. I'm probably just going to get an answer. Now, these two do factor, and something does cancel, but it doesn't actually benefit me to do that. And when I do this, I get 1 plus 6 plus 5, and I realize that is also not a 0. So it seems to me like I end up with a 10 on top of a 12 or a 5, 6. Now, either of these answers would be fine, because you are sitting in a calculus class now, and nobody expects you to simplify a fraction. We simplify selfishly, so this answer is totally fine. If you simplify this wrong and get the wrong answer here, then you're going to take a right answer and turn it into a wrong answer. You should only simplify if you need to reuse the numbers for something. So this answer would have been fine. Had you factored, you would have gotten the same answer because this would have factored into an x plus 1, x plus 4 over an x plus 1, x plus 5. The x plus 1s would have canceled, and you'd get 1 plus 4, which is 5, over 1 plus 5, which is 6. So you get the same answer. And then the last one, right, when I plug in, and I'm going to do that right here just to see what happens, I get a 4 minus 2 minus 2. Well, it's a 0 on the top. I get a 4 plus 2 minus 6. That's also a 0 on the bottom. So I get 0 over 0, which is never the answer, but means that I should be able to factor. So I write limit as x approaches 2. I notice that I'm probably looking for an x minus 2 as the factor, right? Because I have x approaching 2, so x minus 2 would be the factor. So I try x minus 2 and realize that the other factor is an x plus 1. And you can FOIL to check that. You'd get x squared. Outer is a plus 1x, inner is minus 2x. There's your negative x, and you get a negative 2. And then here, I know I'm probably going to get a negative 2, and I realize that the other factor must be an x plus 3, and I can FOIL to check that, but it's right. These guys cancel, and when I plug in, I get 2 plus 1 on top of 2 plus 3, so I get 3/5. All right, so we'll stop this video here. When we start our next video, we're going to go ahead and pick up with E3, and we're going to talk about that next skill, which is foiling and distributing.